Hello folks, this is Dr. DeValley, and this is the first of a series of 3 short videos on how to analyze the food insecurity data from the Food Insecurity Survey. Now, in this video, the statistics covered are descriptive statistics and frequencies. Now, this video covers the output of a simple analysis of the food insecurity data collected by the class. While this is a specific study, the examples discussed in these 3 videos apply to all aspects of descriptive frequency, ANOVA, and correlational statistical results. There are also many good videos on YouTube explaining these statistics and also how to compute them in either Excel or SPSS. Now, this particular video focuses on descriptive and frequency data results and how to interpret the output. In this case, the output is from an SPSS program file. Okay, now, descriptive statistics. Descriptive statistics are used when you have interval level data or high ordinal data. In other words, when your data covers a series of measurements. For example, look at the first row on that table. What is your age in years? That's an example of an interval data where it can vary literally infinitely. The second row is how many children live with you. Well, that's an example of ordinal data. That is high ordinal. In other words, you could have 20 children, but the difference between 1 child and 3 child is not the same as the difference between 1 year and 3 years. In other words, there's limit between these the ordinal data, while the interval data has finite, infinite declinations between each score. Now, let's look at some of the arrows on this table. First, the green arrow refers to the data file that was analyzed. In this case, the food insecurity data, and it was the file version number 4 after I edited some of the variables, whatever. Now, if we look at the blue variables on the left, they point to the specific variables. Okay, the first blue arrow is what is your age in years. On the questionnaire or the Excel output, that is Q008, question 8. Okay, the second blue arrow is how many hours do you work for pay in a typical week. That's also question 11 on the questionnaire. And then on the bottom is the food insecurity scale score. And this scale, the lower the number, the more food insecurity is expressed. Okay. Now, let's look at the first row, whereas what is your age in years? And the first number you see, the N is 138. There were 138 individuals who answered this question. The minimum age reported was 15 years, and the maximum age was 73 years. The mean, where the red arrow points to, is the average age of the people, of the 138 people in our sample. So that's 33.42 years. So we see that this is a mature group. You have mostly adults in there. Now, the standard deviation is that last column, and for that mean it's 11.902. And that means the average amount of variation around that mean score. So in your sample, 65% of your subjects would have an age between 11 years less than 33 and 11 years more than 33. So you would say the range might go from 21 years to about 35 years or 36 years, and that's where almost 2/3 of your sample was found. So you don't have as many old and you don't have as many young, which is good. Now, the whole purpose of descriptive statistics is to describe your data. In other words, if you looked at a list of numbers of the ages of 138 people, you wouldn't know how to make sense of it. But from these descriptive statistics, you could see, okay, the average age is 33 years, and the range went from 15 to 73 years. This is an example of what descriptive statistics look like and getting a picture what they mean. Okay. Now, this next slide is an example, and this next several slides would be of frequency data. Now, frequency data are generally either nominal, for example, like male, female, or they may be a low ordinal, like low, medium, high, something like that, where there's a few discrete groups. Okay. In this case, the black arrow points to what the variable is, and that is what is your sex, which is question 7 on the questionnaire. The red arrow points to the two labels, the two variations to that question. Either the person said they were a female, which was scored as a 0, or they're a male, which is scored as a 1. Now, the other important column that I want you to look at is where I have the blue arrow. And that is the valid percent, which is the percent of your sample. If you look at the second column where it says frequency, there were 90 females, there were 48 males for a total of 138. But 11 people did not answer that question. So the total sample data we collected was 149, but only 138 people answered that question. So that's what the valid percent refers to. And of that, 65.2% of our sample were females, 34.8% were males. So our sample was basically 2 to 1 females over males. Now this frequency slide refers to the variable is how many children live with you. And we see on the red arrow, there's either 55 people said they had no children living with them, 27 people, if you look under the frequency column, said they had one person living with them, and then finally 3 people said they had 5 children living with them. 10 people said they had 4, and so on. And you can see the percents, the blue arrow, the valid percent, is about 40% of the sample did not have children. And it looks like about another 43 or 40% of the sample had 1 or 2 children. And then a few, the rest of the sample, maybe 18%, had 3 to 5 children. Now this scale, this chart, I didn't put any arrows on because now you should know how to read it. This was question 19, object 1. If they answered yes, that they were receiving some kind of public assistance, then what type? In this case, it was, were they receiving the electronic benefit transfer, or called, formerly called food stamps. If they were not receiving it, it is a 0. If they received it, it is 1. And if we look over at the frequency column, you see 120 are not receiving food stamps, and 29% of our sample are receiving food stamps. And in terms of the percent, 19.5%, so almost 20% of your sample receives food stamps. So generally, you can say that overall, our sample represents lots of people who are low income, you might say poor, and also have some indication that they probably suffer food insecurity. Now, this slide, I showed the food insecurity scale as a frequency. Remember, it was also shown above as a descriptive. But here, in terms of frequencies, the scores could range from as low as 1 to as high as 11. And on this scale, the lower numbers indicate more food insecurity. So you see, like, if we look at the valid percents of the blue arrow, but the final column is the cumulative percent. In other words, as we progress up the frequencies, we can see what the percent. So one person represent 0.7% of the sample. Two people plus that one person represents 3.4% of the sample. Three people, the score of 3 on the food insecurity scale plus the score of 2 plus the score of 1 amounted to 11.4% of our sample, or in terms of the number of people, look at the frequency column, that's 12 plus 4 plus 1, so that would be 17 people. Now, so if we look as we go down, I would say a score of probably 6 or lower indicates a fair amount of food insecurity. Not every day, but certainly this happens to the person. They feel insecure about having enough food to eat, usually more than once a month. And the cumulative of the people who had a score of 6 or lower is 33.6% of our sample. So literally a third of our sample are people who experience food insecurity, fairly frequently. So the whole function of descriptive statistics and frequency distributions are to give you sort of a picture of what your sample looks like in terms of gender, in terms of age, but also how your variables are distributed, what they look like. And finally, that's the last slide. I want to thank you for listening and watching, and that's all for now. Thank you.